Hello, this video is to work through exam questions where you have to find enthalpy change from experimental values. This is an OCR F322 paper from January 2011. Okay, first one, it's asking you for the enthalpy change of reaction definition. This at the beginning is nice but not needed for the answer. So the enthalpy change when, and what this is for is the number. Now, the first mark is always about the number of moles. Normally you're specifying one amount that's consistent for all of these types of reactions, but for enthalpy change reaction it's just what matches the reaction given to you. So it's simply put the number of moles of reactants. So it's whatever you've got here, so that's what I'm writing, number of moles of reactants as specified in the balanced equation. So the way the marks were given in this year it's kind of odd how they put it, but normally you give the exact number of moles, say, for combustion formation. Here it's the number of moles of reactants as specified in the balanced equation. So 1 mark for all of that, as in the number of moles here, and then, well, it's enthalpy change of reaction, so that they react together. So there's always 1 mark for the number of moles and 1 mark for the thing that's happening. Okay, on to the actual experimental parts of the question. We have here solid ammonium thiocyanate. Again, they're giving you something you've probably not seen that often. Don't panic about it, just work with the things you've got. It reacts with solid barium hydroxide as shown in the equation below. And what they've done is they've done their solid reactants in this boiling tube, but they've surrounded it by water. It's worth noting as you go through all the bits, okay, we've got a mass of one of the chemicals, we've got a mass of water, slight excess here, great, so this is the one that is the limiting reagent, okay, good, and then it absorbs energy, cooling. Okay, so we need to remember that one for later on. This is endothermic, and that means that we're going to have a positive sign later on. And they tell us the temperature of the water at the start and the temperature afterwards. Right, we have to not rush. We're not going to try and do everything here. This is only worth 2 marks. All I want is the energy absorbed. So we're going to use Q equals mc delta T. First thing, temperature is the easiest one to go with. 21.9 to 10.9, so delta T, 21.9 minus 10.9 equals 11.0. Now in this question, they've been unusually, uncharacteristically generous. They've not told us the volume of water, they've told us the actual mass. Normally they'd say you've got 50 centimetres cubed, and you'd have to remember the density of water is 1, but here they've straight up told you that mass. So it's just about making sure that you use the right mass. There's normally a couple of different masses given, and just using the one of the thing that's actually absorbing, or in this case losing the heat energy. So 50. Now they tell us the specific heat capacity, it's 4.2 that's given here. If you use 4.18 you can still get the marks and you'll get all of the marks, but please do try and read the question and use the values they give you. So 50 times 4.2 times 11.0, putting all of that in correctly would give you 1 mark, and successfully using the calculator to come up with 2,300 joules is good, but RTFQ, they want it in kilojoules, so you divide by 1,000, divide by 1,000, so 2.3 kilojoules. If you'd use 4.18, you could get the correct, you could get both marks are putting 2.299 joules. Right, first step, working out the energy change. Second, it's about calculating the number of moles. Molar mass is what we're going to need, because the number of moles is mass over molar mass. We were given a sample mass earlier in the question of 15.22. So we have 14, 4 times 1, 32.1, 12 for the carbon and another 14, which gives us 76.1. So 15.22 divided by 76.1 equals 0.200 moles. Okay, now the number of moles was 0.2 and the energy that was given out was 2.3 kilojoules. To work out the enthalpy change overall, the first step in this is going to be working out how much energy comes from 1 mole, or in this case is absorbed. So 0.2 moles gives 2.3. What I would do for these is take your energy and divide it by the number of moles each time. So 2.3 divided by 0.2 is going to give us 11.5 kilojoules. However, this is not the end of the story. This is the number of moles of NH4SCN. But if we look at the equation, there isn't 1 mole of it being used. Normally when we do these things, enthalpy change of formation or enthalpy change of combustion, we are dealing with 1 mole. But here, there are 2 moles of this. So we need to know what the energy change is going to be there. So it is 23 kilojoules. Why am I being so lacking in my specificity? Because the question tells me to. So there's 1 mark for having it to 2 significant figures, 1 mark for doing all this, and then it does say to include the sign from earlier. It is endothermic, so plus 23.